what we need to get a handle on are these three very confusing terms. All right. And if you are properly able to understand them, I believe that it will help you unlock engineering economics at least 50%. Okay. There are still other things that need to be learned in terms of time value of money, cost benefit analysis, break even analysis, bonds and stuff. But the point is that with a wishy-washy understanding of interest rate, no matter how much time you spend on time value of money, break even analysis, okay, cost benefit analysis, gradients, annuities, future values, interest rate tables, bonds, taxation, nothing is going to matter. Inflation, nothing is going to matter if you don't get a handle on the interest rate. Okay, so just give me 5-10 minutes and hopefully you'll have a better understanding. Unless mentioned otherwise, any interest rate that is provided to you in a problem statement mentioned on a news bulletin, in a newspaper, wherever you come across, it's considered to be an annual interest rate that is compounded only once a year. Does it make sense? If there is no prefix, no suffix attached to an interest rate percentage, you assume it to be compounding once every year, okay, at that given rate. Now, when we start adding some caveats, some qualifiers to them, then we have to be really, really careful. So the stated or the annual interest rate does not consider the effect of any compounding. It is the annual rate that is compounded only once a year, okay? Once a year compounding is happening. We never use simple interest rate, by the way. We never use simple interest rate anymore. The nominal interest rate is the interest rate or the stated interest rate or the annual interest rate where compounding is happening only once a year. Now, interest rate per period is basically your nominal interest rate divided by the number of interest compounding periods. The way that this starts going in different directions, so this goes in this direction now, and this goes in a different direction, is that I have compounding happening once per year. I have compounding now happening multiple times per year. Okay. These two guys are connected. They're actually different sides of the same coin, whereas this guy is completely different. Are you guys following me? Effective interest rate, by definition, has multiple compounding periods at play. Okay. Interest rate per period means what is the rate in a subset of period. Okay. Less than 1 year. These two are connected and this is basically standalone. Does it make sense, guys? As far as effective interest rate is concerned, what we try to do is we try to come up with an effective annual interest rate that cooks in the effect of multiple compounding periods. All right, I'll show you with the help of an example, it will make more sense. But starting out and keeping these by keeping these in front of you, nominal interest rate compounding happens only once a year. It is also known as stated or the annual interest rate. Effective annual interest rate means that there are multiple compounding periods, but I am going to take all of them into consideration and come up with one interest rate that basically gives me the same effect of all of those compounding periods, but rolled into only one interest rate. Okay. An interest rate per period basically tells you that for each compounding period, and by definition, an interest rate per period, you're looking at more than one compounding per year, then it tells you what is that compounding period. So let's take a look at this example and it will make sense. Your local bank is offering you a nominal interest rate of 6% for the savings account. So how many times is compounding happening if I just stop here? If I just don't read past this statement, this line, this is nominal annual interest rate, 6%. How many times each year 6% is going to be applied on the outstanding principal? Is there any reason for you to believe anything other than one? No. It is only once a year. Makes sense? Only once. All right. Now, the second part of this problem statement is saying that if the interest rate is compounded monthly, now our original assumption of once per year after we continue with this problem statement, is it true anymore? No, because it is compounded monthly. So what are we going to do? First, calculate the interest rate per period and then effective annual interest rate. All right, guys. So now that 6%, we know that we have multiple compounding periods now per month. So there are 12 months in a year. The nominal interest rate is 6%. Okay, this is where you have to pay attention. Now, when I take 6% and divide it by 12, I end up with 0.50%. So, which means that now we are going to compound the principal every month at this rate because there is monthly compounding happening. This builds on top of what was initially provided to us, but this is monthly compounding. This is no longer same as your plain old 6% once per year. Okay, this is how you calculate interest rate per month or interest rate per compounding period. Here, we have taken into consideration that we have 12 months, 12 compounding periods. We have taken into consideration that our stated rate is 6%. We are going to figure out for monthly compounding, what is the interest rate that we should apply. Now, what really brings everything together is annual effective interest rate. Now, the formula is given in both FE Electrical as well as the P Power Reference Handbook. In fact, the entire engineering economics section in those reference handbooks is identical. The goal over here, guys, is that I want to come up with just 1%, okay, that I'm going to apply once a year, okay, to give me the effect of monthly compounding, all right? And that is this formula. And what this formula is telling me is when you punch in the nominal interest rate, which takes only one compounding per year, and the problem statement is saying that actually compounding is happening 12 times a year on a monthly basis. This is that M, and we end up calculating this as 6.16%. Intuitively, you would have thought that if I'm compounding more frequently, more regularly, then the effective interest rate, the amount that I will owe to my creditor is going to be more because the creditor is actually charging me interest more frequently, correct? And that's exactly what it is. So now if I take 6.16%, and this is going to be the aha moment. Let's say we took 10K, right? 10K today, right? And if we are being charged 0.50%, okay? So 10K today, 0.50% plus 0.50% at the end of year one is going to be this amount, right? But this is going to be 12 compounding periods. Are you guys following me over here? Right? Because this rate is being charged every single month, right? So after 12 months, you're going to get this amount. Can somebody do this calculation? Whereas if I'm using annual effective interest rate of 6.16%, I'm going to do this 6.16%. And what will be the value over here? Just 1. Because I've cooked in, right, the effect of multiple compounding periods using this formula over here, right, into this one equation. All right, 15K, I don't think that's right. This is 0.50%. So you have to use it as a decimal, 0.005, I believe. Okay. Yeah, so that sounds more right. 616. Okay. Yeah. And what about this? What do we have over here? 1 plus 6.16% raised to the power of 1 multiplied by 10K. Okay. What is this? Same amount, right? 10,616. Does it make sense? Can someone confirm that these are the same? All right. So let's take a step back and see what happened over here. If you can spend 1 minute, 60 seconds or less, understanding the difference and the similarities in all three of them, my job is done, right? You basically walk away from this session appreciating what the nominal annual interest rate was, what was our interest rate per period, how we ended up using it, and what was our annual effective interest rate. So this guy, 6%, okay, stated rate, annual rate, nominal rate, just told you that, hey, This is the market rate going on an annual basis. This is what the bank is offering. We're going to charge you 6% once per year and off you go. But then your terms and conditions for your mortgage, for your loan, whatever you're doing, car financing and refinancing, whatever it is, it says that, what? We are actually going to charge you compound interest on a monthly basis, right? Then you go back and you're like, okay, let me figure out if it is compound interest on a monthly basis, then my cost of borrowing is not going to be just simple 6% per year. I want to look at it, how it's going to impact me on a monthly basis. And what if I roll everything up into one interest payment, right? When you look at this, you're like, compounding is happening on a monthly basis. So this is how many time periods, guys? 12. This is where 12 is coming from. And you can come up with quarterly, you can come up with daily, you can come up with multiple variations of that, semi-annually, okay, weekly. And then you are like, 6% is the annual rate, but essentially I am basically going to be, this is my interest rate per period, okay? The number of periods become very important over here. This is 0.50, which I'll be charged every month. Now, this is linked to what is our nominal interest rate, what is our annual interest rate, what is our stated interest rate, for which there is only one compounding per year. Okay, but it is different because we end up using this interest rate for 12 periods, not for once a year. Clear? Now, there are scenarios, and in my program, both FE Electrical and PE Power, we work through time values of money, annuity gradient, where the payment frequencies are, let's say, once a year, but compounding is happening monthly. Okay, are you guys following me? The payment frequency, annuity by definition, is once per year. Okay, but compounding is happening monthly. In that case, we have to somehow take into consideration what is the effect of compounding, which is happening monthly. But since my payment frequency is once a year, I need to convert that into one interest rate that captures it. And that's where the annual effective interest rate comes into play. Are you guys following me here? So this guy is different from the nominal annual interest rate in that it does take into consideration the monthly compounding that happens. Okay. It is similar in the sense that we can apply it once a year and get the effect of monthly compounding. It is different from the interest rate per period because we only have one compounding period. Okay. So when you see this, I used 1 over here, right? Because our compounding period was 1. But it is similar to interest rate per month, interest rate per period, in the sense that it takes multiple compounding into consideration. Okay. Now you can imagine that you have a full-blown 1-paragraph question on the FE Electrical exam or the PE Power exam. Okay. And interest rate essentially is your starting point. And then it asks you to do cost benefit analysis, break even analysis, time value of money, gradient, annuity, a combination, the whole 9 yards. Do you think that if you don't make a correct assessment of the interest rate, if you don't start out with the interest rate properly, do you stand a chance solving that problem down the road? Because that analysis has not even started yet. Whether you end up using 0.50, okay, whether you end up using 6.16 or 6%, okay, and then combining it with the right compounding period to use in your calculations. These are essentially 3-4 different paths you can take, and you cannot sleepwalk your way through these problems. And that's what makes engineering economics challenging. All right. And this slide over here gives you an idea that if you're starting with a 10% annual interest rate and we start increasing the compounding periods, and you can prove this to yourself, this is essentially annual effective interest rate formula in play. Then if you're doing semi-annual, like twice a year instead of once a year, your effective annual interest rate is 10.25, quarterly, monthly, daily. And each one of these calculations, when they fed into the present value, when they fed into the future value, when they fed into annuity, gradient, break-even analysis, cost-benefit analysis, taxation, bonding, inflation, is going to pump out different answers. I hope you extracted some value out of it. And if you're interested in a streamlined exam preparation resource for FE Electrical and PE Power Exam Prep, then please visit my website, www.studyforfe.com. You'll find a lot of details over here, and feel free to send me an email. And I look forward to seeing you guys if you pursue with this in my program and fast tracking your exam preparation.